So now let's work out a few examples of estimating population proportions with confidence intervals. Duff Brewery purchases aluminum cans from an outside vendor. A random sample of 80 cans is selected from a large shipment of cans, and each is tested for strength by applying an increasing load to the side of the can until it punctures. Of the 80 cans, 58 met the specification for puncture resistance. What is a 95% confidence interval for the proportion of cans in the shipment that meet the specifications? Okay, so we want a 95% confidence interval for the proportion of cans that meet the specifications. So alpha, in this case, would be 0.05. Okay, 95% confidence, therefore alpha is 0.05. And we know that we witnessed a sample of size 80 cans. Okay, and in those 80 cans, we found that 58 met the specifications. Okay, after we did our strength testing, y equals 58, we're good. So what is our estimate, our point estimate, for the proportion of cans that meet specifications? That is p hat, okay, that's how we denote the sample proportion, and that is 58 divided by 80, okay? That happens to be 0.725, okay? 72.5% of cans meet specifications based out of this sample of 80, okay? And we need, for our confidence interval, we need a value of z, okay? So alpha is 0.05, therefore we need alpha over 2 in each tail, 0.025. Okay, z of 0.025 in each tail. So what do? We go to the z lookup table and we find a value of 0.975, okay, at an intersection, and then see what the row is. That happens to be 1.9, and then the column is 0.06. So our value of z is 1.96. Okay, so now we have everything that we need for our confidence interval. The way we calculate a confidence interval for the population proportion based on a sample proportion is with p hat plus and minus z alpha over 2 times the square root of p hat 1 minus p hat over n. Okay, this is our confidence interval within which we think the true population proportion lies. And again, this is a point estimate plus and minus a margin of error, where the margin of error is a function of variability in sample size and confidence. Okay, so let's put all these values into this equation. That is p hat 0.725 plus and minus z alpha over 2, 1.96, square root of 0.725, 1 minus 0.725, all over n. And n in this case is 80. Okay, that's just arithmetic. We can do that pretty easily. We've got a lower bound here of 0.627 and an upper bound of 0.823. Okay, so what does this say? This says that the population proportion of cans that meet specification lies somewhere between 0.627 and 0.823 with 95% confidence. Another way to say that is I'm 95% confident that the percentage of cans meeting specifications in the population would be between 62.7% and 82.3%.